it visible to you?
Yes, sir, it is visible, sir. Now, yes.
Okay, so in the last class we discussed this topic. This was the last topic. Angular momentum of a single particle about a point. Is this clear?
Yes, sir, it is
This
clear, sir.
this topic is clear. You understand this? Okay. So you can find angular momentum of a particle about a point, and that is given by this formula. It is r vector cross p vector. Where p vector is the linear momentum of the particle. After that, I gave you a relationship between the torque and the angular momentum. Here you can see that this is the formula of angular momentum, and if you differentiate this equation on both sides, you will get dl by dt is equal to r cross f, and you know r cross f is the formula of torque about that point. So angular momentum and torque about a point has this relation. Rate of change of angular momentum about a point will give you the torque acting about that point. Is it clear?
Yes, sir, it is clear, sir.
Okay. So now, based on this, I gave you one question in last class. You solved this question or not? If you want, you can try this question, or you can just explain how you will do, and then we will move to the next. This is a question asked in JEE Advanced. You have to simply calculate the magnitude and direction of angular momentum of the particle about point O. So this is very simple. Here is the particle, and you have to find its angular momentum about the origin. So simply what you have to do is r cross p. But here what is given is that it is projected with a speed u at an angle of 45 degrees. So from here, when it is projected with a velocity u, and this angle is 45 degree that is given to you. Now this is the time at time t equal to u by g. Now if you see carefully, this time is the time when the particle will reach. Where will be the particle at this time?
At maximum height, no, sir.
So check it whether it is at maximum height or not. Theta is 45 degree.
No, theta, then it's half of maximum height we can explain.
Okay, so it is at some point. So
At
you
some point,
simply have to do r cross f, r cross p, and this r, you can say that this r is nothing but this vector is r vector. Is it visible? R vector. And you can say r vector is nothing but x I cap plus y j cap, right?
yes, sir, exactly.
So this is addition of these two vector will give you r vector, which is x I cap y j cap. Suppose that the coordinates of the particles are x comma y. Now you can easily find x and y because u and theta is given, and time is also given. Are you getting? So x will be u cos 45 into this time u by g, and y will be u sine 45 minus half gt square. T is this. So you got x and y. Once you got x and y, then the angular momentum about point O is very, very simple. Angular momentum about point O will be simply r cross p. So r cross p you can write as r cross p. So r cross p you can write simply as r vector you can write as x I cap plus y j cap, x I cap plus y j cap, and x and y you will get by equations of motion, substitute, and then it's cross product with p vector. Now what is p vector here? So for that you will have to find theta also. To write it in vector form, you will have to find this theta angle also, right? This angle you can find as it will be tan theta is equal to Vy by Vx, right? Are you there?
Yes, sir. Yes,
Are you there or not there?
sir. I'm there. Hello, sir. Am I audible or not?
Okay,
Hello, sir.
but your voice is not audible.
1 minute, sir. I'm using another phone. Sir, now am I audible, sir?
Yeah, still it is low, but okay. So now you can find theta, you can find easily, and you can write tan theta is equal to here Vy by Vx.
VX, yes, sir.
Vy automatically you got u plus at because you know u also it is u, and theta also you know, and t also you know. So and Vx will be u cos 45. So just put it, from that you will get theta, and then here you can write cross product with the momentum, and momentum is mass times velocity, and then velocity again you can break into components. So mv cos theta I cap, mv cos theta I cap plus sorry minus, because mv sin theta will be downward, mv sin theta j cap, and then take cross product, you'll get the answer, right? And then at the end, if they are asking you just the magnitude, then you just take the mod. Here if you have any doubt you can ask.
Sir, no doubt, sir.
Okay, so if you have no doubt, then try this question.
If yes, cylinder is given.
Do it fast, draw diagram according to the question, and then try to do it. And in solving this question you will face some doubts, then you can ask any doubt related to the question.
The cylinder is given with the cylinder is given angle is omega. Upon a horizontal rough surface, the initial velocity is zero. Initial zero energy channel. Cylinder on the ground మీద ఉంది then drop in at initial of zero నుంచి zero అనుకుంటే so distance traveled by cylinder before you perform. Hmm. Sir, what is a any is any special condition for pure rolling, sir?
Yes, so we have not discussed pure rolling.
Sir, no, sir, we have not discussed it.
Okay, so we'll discuss pure rolling first, and then you can do these questions. So let's go back. Okay, so leave this question. We'll do it in today's lecture after doing pure rolling. So now let's talk about angular momentum of a body about an axis. See, in the last class, we discussed angular momentum of a single particle about a point. But now we are talking about angular momentum of a whole body, and not about a point, about a fixed axis. Okay. See, whenever you have to find the something for a whole body, you have to understand that the body is nothing but system of particles made up of large number of particles. So if you already define the angular momentum of a particle, In the same way, you will find the angular momentum of the body because the body is made up of large number of particles. So what you will do to find the angular momentum of a body is you will find angular momentum of particles of the body, and then you will add all the angular momentum of all the particles. And in this way, you will get the total angular momentum of the body. Now, here you have to understand that if suppose this is a rigid body and the body is fixed to rotate about a given axis, then if you look at the individual particle motion, you will find that all the particles will actually move in circle. So if individual particles move in a circle, you know, then how to find angular momentum of a particle? Suppose there is a particle at some distance ri and its mass is mi, and because it is going in a circle, so r cross p, if you will do, its radius vector will be always perpendicular to the momentum vector because the particle is going in a circle. Is it clear?
Yes, sir. It is clear, sir.
So then r cross p will become rp sine theta, and theta is 90, so it will become rmv. So you can see here rmv, and you already know v equal to r omega. So from that formula, you are getting m r square omega. Now, if you do the same for all the particle, you will do summation of all mi ri square into omega because all the particle have same omega. So if you take omega common, it will become omega times summation of mi ri square, and summation of mi ri square is I. So you got a simple formula that angular momentum L is equal to I omega. Now here you have to understand, whenever this I comes in any formula, you have to understand I will be defined about an axis. So clearly here L represents angular momentum about the axis and I represents the moment of inertia about the same axis, right?
Yes, sir.
So whenever you have to find angular momentum of a body about an axis, moment of inertia should be also about the same axis. Angular velocity should be also about the same axis. Okay. Now, here also, if you differentiate this equation on both sides, what you will get? dl by dt is equal to I d omega by dt. And d omega by dt is alpha. So it becomes I alpha. And you already know that dl by dt is also nothing but torque. So then I alpha became equal to torque. Now this is a very powerful equation. dl by dt equal to I omega, I alpha is equal to external torque. This equation is very, very useful. You have any doubt in this equation, you can ask.
Sir, no doubt, sir, in this equation.
Okay. So now you can try this question. This is a simple question asked in JEE mains exam. Just do it quickly. I will show you the diagram also. Just do it fast. Just write the equation.
Yes. Two small worlds of two small worlds of mass and each of each. Okay. Two mass. Each attached to a right side of something like the same. Length and one of its one at its center, another at the union. The road is fixed of the other end and is rotated in horizontal. respect to each of the ball are the with respect to the ball itself. Calculate the angular moment of the ball at the end with respect to the relate to angular momentum. Okay, relate to angular momentum. So I mean, he's asking to find just the relate to angular momentum. I think, Samus.
Hmm. Yes.
Yes. Okay, this is the fluid which is there. We can angular momentum of the ball. Angular momentum is I got close when it was ball A. I will be ml square each apparatus center if it is a center and by L by 4 ml square by 4 ml square omega by 4 center LCM divided by omega square. So 3 by 4 m omega L square we can get.
Okay, let's see. 3 by 4 m omega, that is wrong. 3 by 4 you said, right?
Yes, so one is 1 by 4 and it's m omega L square. So 1 by 4 m omega L square.
So first is,
So for the
tell me what.
so for the ball A, sir, it will be m omega L square by 4, no, sir. And for body B, it will be m omega L square, no, sir. Because of the length of L and L by 2. It's asking the relative angular momentum, no, sir. We can subtract LB minus LA, we can do, no, sir. Then we get
Hmm.
4 minus 1, 3 by 4 m omega L square. Both the balls A and B have same angular velocity but different angular velocity. The situation is the velocity with respect to the
Here you can do directly. Suppose what you have to find. You have to find angular momentum of B with respect to A. Okay, means where with respect to what? With respect to A.
sir.
Yeah.
Sir, here also the answer is 3 by 4 only, sir, because 1 minus 1 by 4 no, sir, here. Means 3 by 4 only, no, sir.
No.
Sir, in the L, he mentioned L equal, okay, sorry, sir. It equals to, sorry, sir, I thought minus. So even if you do directly we can do, for by using formula for body A, it will be m omega into L square by 4, no, sir.
But that will be about O, no?
So here also we need to, oh, understood, sir. It's asking to find with respect to ball at center. Yes, sir, sorry.
So if you sit here,
Yes,
what
sir,
you will
sorry, sir.
see that this is moving with how much velocity? So omega L minus omega L by 2, right?
Sorry, sir. I thought with respect to point one.
Which gives you omega. So this is the correct process, and like this you can do.
Yes, sir. Yes.
Okay, so let's go to the next. And now this is very, very important. Lot of questions comes from this, which is the conservation of angular momentum. Okay, this says that if there is no net external torque about the axis, then the angular momentum of the body will remain constant. So there are two forms of this conservation of angular momentum. Here you have to understand that if there is no net external torque, then angular momentum of the body will remain conserved. about any axis if there is no net external torque. But even if there is some external torque, angular momentum of a body may be conserved about some axis. For example, if there is external torque about y-axis, but no external torque about x-axis, so angular momentum of the body of the system will remain constant about x-axis and y-axis. Are you getting? Means angular momentum of the body will change about an axis only if there is an external torque component about that axis. Are you getting?
Yes, sir, I'm
If
getting,
there
sir.
is no external torque component about an axis, then angular momentum of the body about that axis will remain conserved, but maybe about some other axis not conserved. So you have to see that angular momentum we are dealing with is about which axis, and then you have to see that is there any external torque component about that axis. If there is external torque, angular momentum will not be conserved. If there is no external torque component, there is external torque, but there is no external torque component about the axis, then also angular momentum of the body will be conserved about that axis only. Are you getting?
Yes, sir, I'm getting, sir.
Okay. So if you are getting now, start with this simple question first. So this is JEE mains question. You can try this one. Try this question. Try this.
पूछना चाहता हूँ कि ये जंक्शन पे चार्ज आया कहाँ से पॉजिटिव चार्ज कहाँ से आया जो अकोमोडेट हुआ है तो नेगेटिव चार्ज कहाँ से आया जो अकोमोडेट हुआ है आंसर तो निकाल लिया है ये बहुत से लोग लगा के आंसर तो मैच करा उसमें कोई दिक्कत नहीं है मैथमेटिकली करना है थ्योरेटिकली भी मैच नहीं कर पा रहा कि वो चार्ज कहाँ से आया है
Sir, can you zoom that question? Sir? It's letters are too small to see.
Okay. Tell me what you said.
Sir, can you somewhat zoom the question, sir?
Zoom the question. Okay.
Yes, sir.
Yes, yes.
Yes, sir, now we can see, sir. Thank you. A uniform rod of mass and length L cannot be freely first to cool can rotate freely on a smooth horizontal plane. Hmm. A point mass hits the ball perpendicular to that. Okay, not generally elastically means everything is conserved. Okay. Find out the angular velocity. Okay. Here the angular momentum is conserved at the point H because there's no torque is acting about it. Okay, about how we can get initially equals to final initial linear velocity at this point of m equals 0. ml square is equal to ml square plus so 3u by 4l, sir.
3u by 4. Okay. So
L, sir.
let's check it.
Yes,
That is
3u by 4l.
3u by 4L.
Yes, sir, 4l, sir.
That is the correct answer of this question. Okay, so I'm giving you one more question and try this and then we'll proceed to the next. This is again a JE advanced question. This is JE advanced. Last was JE mains question.
Uniform mass of human and stillness when plan a particle of mass okay, m to move within speed v naught.
Are you getting answer? Any doubt you have?
1 minute, so I'm
Okay.
understanding the question. So this is
Okay.
uniform lot of mass. Okay, okay. And it's like another part. The velocity center of the road. Okay, velocity center of the road. I'm not going to the road about and then the velocity center of the road. I'm going to road about its center just after the collision. So collision means which collision we need to consider? Sir, it's an elastic or which collision we
Sorry.
should, sir, which collision we need to assume, sir, it has elastic or any other collision, any particular class of collision we need to assume, sir.
1 minute. Friction is a particle once perpendicular strikes at a distance now from the stops after the collision. Okay. So the velocity of center of the road, angular velocity. Take it as elastic collision. Take it as elastic.
Sir, what are the properties of elastic? All properties. Okay, when elastic momentum is conserved, your kinetic energy is conserved. We can say, sir, speed of velocity can be m2 by m1 into v naught, we can say, no, sir. Because if you
Okay.
consider it as a elastic collision, the momentum can be conserved, no, sir, immediately.
Yeah, momentum. By conserving momentum, you will directly get the.
Get the speed, sir,
Uh,
velocity.
but momentum conservation has nothing to do with elastic collision. Even for inelastic, momentum is conserved. Even for inelastic collision, momentum of the whole system is conserved. Momentum of the whole system is always conserved, whether it is elastic or inelastic.
Yes, sir. So only if there is no external force acting on a body, no, sir.
Yes,
All
no external force here. Yes. Okay, now B part. Go for B part.
angular velocity of the road So we can apply V equals to R omega formula directly can we get it because it's the velocity of the rod after the collision of the
Hmm.
nozzle. By using the relation between linear and angular variables, we can get the answer. Nozzle.
Hmm.
Then we can get both answers. Nozzle. Omega equals to V by R. It will be.
Hmm. Correct. So check your answer is coming or not. So
Um,
okay, that is concept is correct. You will get the answer. In second part, what you will do? You will conserve the
angular moment also we can cancel. Nozzle.
about.
So about point O we can.
Uh,
Sir, either like that, we can directly use V equals to R omega and we can get the omega, sir. Because in the first
no,
question we obtained the speed of
no, you
velocity.
cannot get V equal to R omega because
Why it will be
uh,
true?
so V equal to R omega. First of all, you have to understand that this is only true if the body is in pure rotation, only rotating. But here, body is not only rotating; it is not fixed about an axis. No?
Sir, it can translate. It's translate.
So it is V is separate, omega is separate. There is no connection between V and omega here. Are you getting?
I'm getting sense.
The body is not fixed, the body is free. Okay, so now the next topic is the same thing that it is combined translation and rotation. Combined translation and rotation means that the body is not fixed about an axis. If the body is fixed about axis, it can only rotate, no, not translate. So here you have to understand that if simply suppose you take a plate and you just throw it so that it is also rotating and it is also moving, or you can take a stick or you can take a rod and you can throw it in air in such a way that it is also rotating and also translating. So these are the examples of rotation plus translation. In rotation plus translation, you have to understand that the motion is actually translational motion of the whole body, which can be replaced by the translational motion of COM, and rotational motion of the body about the COM. Means if this is the body is translating as well as rotating. Translation, you can simply replace the whole body by a point at its center of mass. So now this is the velocity of COM. Why I'm saying that you can replace the whole body by a single point to represent its translational motion, because due to translational motion, all the particle of the body is moving with the same velocity, VCOM, all the particles. And all the velocity are in the same direction due to translation only, I'm saying. But there is rotation also that you will deal separately. Now rotation is all the particles are rotating about, so about its COM. Whenever a body will be free, no external force is there, it will naturally rotate about its COM only. It cannot rotate about any other point if it is free. So the motion of whole body is simply motion of COM plus motion about COM. About COM, all the particles are going in a circle with respect to COM. But the COM is also moving, center of mass is also moving with this velocity. So every particle motion is complicated because every particle has some trans, is not going in a circle because it is not pure rotation. So it is moving in a complicated path. But you can simplify the whole motion by simply saying that the whole body motion is represented by the velocity of com, translational motion, plus rotational motion about the com. Now here you can see that suppose if this is a rigid body, so if this is a rigid body and there is a point B and there is a point A, particle B and particle A of the body. You have to understand that the body is a rigid body, means this AB distance is not going to change. So with respect to A, if you see, what will be motion of the B? If a rigid body is moving in such a way that it has translational plus rotational motion, that is called a general motion of rigid body. So if a rigid body is doing translational plus rotational motion, then what will be velocity of, what will be motion of particle B with respect to A? So when you are sitting at A and you look at the motion of particle B, you will find that the particle B is moving in such a way that this AB distance is not changing. Why AB distance cannot change? Because the body is, see this, body is a rigid body. Means with respect to A, B can only move in a circular path, right? So when a rigid body move, motion of any one particle of the body with respect to another particle of the same body is always a circular motion. Are you getting it?
Yes, sir, I'm getting, sir.
Okay, so now you can try this question. Try this question. You can ask your doubts. Tell me, you have any doubt? You can ask.
So 1 minute they're doing, sir.
Hmm. Tell me, you have any doubt? You can ask. You can ask your doubt.
So 1 minute, sir. Yes, sir.
Okay.
Yes. Velocity of A with respect to dt, velocity of B with respect to O, C with respect to A, velocity of A with respect to O equals to V equals to R omega, but it's given the velocity with we formulate rotational we can get V equals to R omega. So V equals to R omega is not. That's both translation and rotation combination that would have translation equivalent Sir, here I'm not getting such this answer. Here we cannot use V equals R omega naught. That is how we can find the linear velocity relationship.
Okay. So what we can do then, and why we cannot use V equal to R omega?
So you said that we can use only that relation if it's in pure rotation motion, no sir.
Yes,
But it is
that is
moving with a linear velocity V also, no sir.
yes,
So
correct. See, when you say V equal to R omega, what is V?
the linear velocity, sir, and speed
Of
we can say.
of what? Linear velocity of what?
Sir, of the particle or the
Of the
yes,
particle. Remember very carefully. Of the particle of the body, not the center of mass of the body. Are you getting?
yes, sir. I'm getting. Sir.
When you say V equal to R omega, V is velocity of one
Particle.
particle of the body, not the velocity of center of mass.
Yes.
Here, V will be equal to R omega, but then V is velocity of COM. V equal to R omega is correct here, but this V is not velocity of a particle, it is velocity of COM. But now before that, you have to understand that why V equal to R omega is applicable here. So is this a case of pure rolling? First of all, that is
Pure
not written anywhere. It is simply a general motion. Okay. So if it is a general motion, not written pure rolling, then we cannot say V equal to R omega or anything. So let's apply the general concept here. Here, no requirement of V equal to R omega. Why you are thinking V equal to R?
the pure rolling means what? So difference between pure rolling and
V equal to R omega
sir,
will
if
come
body
if
is
the
rolling,
body is doing if a particle is moving in circle, and particle move in circle about only if the body is doing pure rolling, right? Sorry, body is doing pure rotation. Now here, velocity of A with respect to O, right?
yes, sir. A with respect to also.
So focus on velocity of O and velocity of A. So what is velocity of O?
The V is directly V we can say, no, sir. Center of mass.
And what is the velocity of A point? So now A point will have two velocity.
It's a linear
Why
and
two
angular only.
velocity? Because of linear and the angular
Angular
motion.
motion.
So because of linear motion, its velocity will be V. And when you say angular, now you are only talking about angular and not talking linear, right?
Sir, no,
Because
yes, sir.
linear you have already taken V. So now when you are taking only angular, then it will be R omega, because only angular means only rotation you are focusing, right?
Sir, here linear will be in opposite direction, no, sir.
No, why opposite? Like V equal to R omega will be always in the direction of omega cross R. So in this direction.
So because sir, generally velocity determines the direction of motion, no, sir. The particle is moving in the clockwise, no, sir. Means the if the velocity. Uh,
No, forget that. Always velocity, when you say of a particle is due to rotation, only rotation, when you say the velocity of a particle and you say V equal to R omega, so actually it is V equal to omega vector cross R vector. It is also the same in the circular motion chapter also.
yes, sir.
So always apply this. Always it will be true, omega cross r. But
Sir,
here you
with
have to understand that this velocity is only due to rotation. Means right now you are ignoring translation. Are you getting?
sir,
So if you do rotate omega cross r here for particle A, you will see omega cross r comes in this backward direction. Tell me, you can ask your doubt now.
sir, with so generally in the kinematics we say that in which direction the velocity is at a particular instant of time, in that direction the body is moving, no, sir, at that instant. Sir, when here the particle is going in the okay. Sir, the particle A
So
means
first of all, here you have to understand that what you are talking is a totally different thing, because you are talking about particle, and here you are talking about particle but relating it with velocity of com. So these are two different things. If a particle is moving in east, its velocity will be in east. But
yes, sir.
here it is not a particle which is moving in this direction. Are you getting? It is the com which is going in this direction, right? So here the
Sir,
thing is totally different. Here you cannot apply the same concept of particle. Here you can apply, you know, because here there is no particle, there is a body here. And when you say velocity of of the body is to the right, then body is to the right, no, not the particle. For example, if a fan is moving, So what is the velocity of the fan? If I ask you, what is the linear velocity of fan? Ceiling fan.
R omega we should omega bar plus alpha then.
So when I say linear velocity of the fan, it means linear velocity of what?
Of center of mass of the it
Of
depends upon
center
the
of
choice of
mass.
but
And
there
what
is
is the velocity? Yeah.
but the center of mass is not moving sir, for the fan.
So then what is the velocity of the fan? Linear velocity.
So it depends upon the particle which we choose on the blades. It depends
No,
no,
I am asking you linear velocity of the fan. What does it mean?
it means the linear velocity of center of mass we should consider no, sir.
And what is that? What is that?
Zero sir.
Zero. So linear velocity of fan is zero. But the particles of fan velocity is not zero linear velocity. That is
Yes
what
sir.
I am trying to tell you, that velocity of body is different, velocity of particle is different. Are you getting?
Yes sir, I'm getting sir.
So you are confusing between the two things, velocity of body and velocity of particle. When we say velocity of body, we talk about velocity of COM. So here, because of rotation, velocity will be in backward direction, and because of the translation, velocity is in forward direction, and this velocity is velocity of COM. है
Sir.
ना? So now here, what will be the net velocity of point A? Net velocity of point A will be, if I have to write in vector form, I will simply write, or I can simply write V and minus R omega. This is the velocity, okay, of the particle A. V minus R omega. This is the answer of your first part, this part. You can ask your doubt.
Sir here
Hmm.
point A. Sir
This answer of
point
this
A.
part. Yeah.
Yes sir. Sir here point A means the point we should consider a fixed point on the body or the point where the body on the ground touching that point as A sir.
Okay. One more thing here you have to understand. No, A is the A is the particle of the body, not the ground. Ground is at rest, so that
So no,
actually
it's
they are not
common
asking
surface
us
I'm asking.
velocity of. It is not. They are not asking velocity of A. I calculated velocity of A, but they are not asking velocity of A. They are asking velocity of A with respect to O. So then it is only R omega, because it is with respect to O, no? So with respect to O, it is only doing pure rotation, right? So then only R omega. See, here it is written already in the question. Read this line.
Yes sir. Velocity. Oh and yes, sir.
So then only R omega. So I have not calculated velocity of A with respect to. I have calculated velocity of A, that is with respect to the ground. That is V minus R omega. But the answer of the first part will be only R omega. And you can write minus R omega I cap, because it is in this direction, right?
Yes sir, it will be in that direction.
Yes. So that is the answer of first part. You can just try the second. Means this one. Velocity of B with respect to O.
Sir means
Here
sir
is
if you
particle.
consider so if you consider the point A as the common means we can assume that point A as the common point of touching of the ground and the body, no sir. At that point the velocity remains constant, no sir. We can say as the body rotates.
When you say constant means what?
Sir means velocity of that point will be always V minus R omega only, no sir. So because always the
The
body will
touching
be in constant
point
with
will
that
be V
point only,
minus
no
R
sir.
omega. That is correct.
Yes sir. Okay, understood. In this case, the point also moving we should consider, sir, or it is at that time not getting somewhat
Which
confused.
point? Which point?
Sir, sir, if he's saying that in the figure that is point A, no, sir.
Yeah.
Sir, means it is the common. touching point of the that rotating body
Yes,
and
of
ground,
the
sir.
ground and the body. Yes,
Means always that point will be at, it will be at, we can say rest, no sir, then.
it will be moving with this velocity, not at rest. Why at rest? Tell me.
Sir, always the body will be touching with the ground only, no sir, then.
Yeah, touching ground, but then slipping with respect to ground. Not always touching. At any instant, it is touching. Touching, but then touching does not mean that there is no slipping. Touching, but slipping. Ground is at rest. This point is moving with some velocity. So this is not a case of pure rolling. Are you getting?
Yes sir, I'm getting.
Here, the point of contact is not at rest, but it is the point of contact. So touching, contact, point of contact, but not at rest. Moving with this velocity. Why it should be at rest? There is no condition it should be at rest. Again, you can ask. Keep asking.
Sir, sir means as then we need to assume the point is as on the rotating body only, no sir.
Yes, it is of the body. It is not of the ground. It is of the body only. But that point of the body is in contact with some point of the floor, na?
Means at that particular time only it is in contact, we can say,
At a
no sir.
particular instant, it is in contact. At one instant, it is in contact with some particle of the floor.
Yes sir, understood sir. Now I understood sir.
Okay.
Yes sir.
So let's go to the. You calculate the velocity of the next particle.
Yes sir. Yes, sir.
You have to forget this question. Don't solve this. Solve this. Find velocity of B. Not B with respect to A. Find velocity of B. This one.
Yes. Sir, here center of mass velocity will be in horizontal and rotation will be in vertical also at 90 degrees. Means we should write it in vector form also. The velocity of V will be velocity of center of mass I cap minus velocity of rotation J cap also.
So J cap or minus J cap that you have
Minus
to
J
say.
cap, sir. Minus J caps.
Okay. So what will be the equation like this? What will be the equation?
Yes, sir. V I cap minus R omega J cap. We can say.
Huh. That is correct.
Yes.
That's it. Now comes the case that you were talking, pure rolling. Now, pure rolling is just like the previous question, that there is contact and the contact point is at rest at every instant. So, if a body is moving on the surface in such a way that its center of mass is moving and the body is rotating about COM, but this point of contact is at rest with respect to ground, then it is called as pure rolling. Point of contact is at instantaneous rest with respect to the ground. Point of contact will keep on changing because the body is moving, so a new point will come to contact.
Sir, means we
But at
can
every
consider.
instant, there will be some particle in contact, and at that instant, that particle velocity must be zero with respect to the ground, which is in contact. So, that particle of the body which is in contact with the floor, that particle velocity should be zero only at that instant, not after that instant, because after that instant another particle will come in contact with the floor. Are you getting?
So means the body is moving, having translation motion also, sir. Here.
Yeah, so the body is moving as well as, means translating as well as rotating.
So then, what is the difference between previous case and this case?
No,
Both are.
the only difference is that now the omega and v value are so adjusted that this point velocity comes out to be zero with respect to the ground.
So
In
means we
earlier
can
case,
yes.
yeah,
So means we can assume a fan rotating vertically, sir. Means
no,
so then only
because
V and omega
because
can be utilized.
a fan rotating vertically is just pure rotation of the fan. About the axis of the fan, it is rotating. No, are you getting?
Sir, if it rotates in that way only, V will be equals to R omega, no, sir. Uh,
Means if the fan so you are saying fan is rotating about the axis of the fan, right?
sir, no, sir. If we catch with our fan with our hand and we switch on the fan, it will rotate in the vertical
So
plane, no, sir.
forget for why you are saying fan, you can take a better example. You can say ring is,
Sir, it's sir means
yeah,
it, sir, pedaling the cycle wheel by using stand, the wheel rotate at that point only, no, sir, without moving.
that is
That
that is rotation only, no, only rotation, there is no translation.
sir, but in those cases only V will be equals to R omega. Then only the body, then
Yeah,
only that point will.
yes, but then v is velocity of particle.
Yeah,
V will be equal to r omega, but v is velocity of the particle now. Here also v equal to r omega, but v is not the velocity of particle. V is velocity of COM. Are you getting the difference? There is a big difference. There v equal to r omega and v is velocity of a particle of the body, not the body. Are you getting?
yes, I'm getting.
Here v equal to r omega, but
Sir,
v is
okay,
not the velocity of particle. V is the velocity of the whole body, means velocity of COM.
sir.
That is the
Yes, sir.
big
Yes.
difference. Understood?
Understood, sir. Yes.
Yes. So here also v equal to r omega. There also, but this v, that v is totally different. Okay. So now here you have to understand that whenever a body will be in pure rolling, then velocity of the point of contact. So let's say that point of contact is A. With respect to the, let's take a particle of the ground which is in contact, or the floor which is in contact. Let's call that particle as P. A and P are in contact, where A is particle of the body and P is particle of the floor. So velocity of A with respect to P must be zero, then only we call it as pure rolling. This is the only condition. V equal to r omega is not the condition. Are you getting? This is the condition, that when the velocity of the contact point of the body is zero with the contact, with respect to contact point of the floor, then we say that the body is in pure rolling. That's it. There is no other definition of pure rolling. V equal to r omega is not always true for pure rolling. This is always true. I can give you one question. So suppose that this is a plank. This is a plank which is kept on a horizontal surface. So let's take, this is a horizontal surface, and on that surface this is a plank. Are you there?
Yes, sir, I'm there, sir.
And on the plank, there is a, let's say, a cylinder or a sphere, anything. It is touching the plank. And now it is given that the plank is moving, let's say in this direction with velocity v1. And the sphere is doing pure rolling on the surface of the plank, and its velocity is, let's, velocity of com is, let's say, v2. And then you have to find the relationship between v1 and v2. Also given that it is rotating with some velocity, with some angular velocity, let's say omega. So now you have to find a relationship between v1 v2 omega. Understood the situation? Ground is at rest. On the ground a plank is moving, and on the plank a sphere is doing pure rolling. You have to find a relationship between v1 v2 and omega. And one more thing, all the velocities are given with respect to the ground. All the linear velocity, and angular velocity is about the com. Understood the question? Understood the question? Are you there?
Sir, I understood the question, sir.
Okay, try this. Tell me, got the answer?
Sir, I'm not getting certain response in pure rolling.
So you have to only apply this concept of pure rolling, which is this. This is the concept. Only this.
Sir, I'm not getting the difference between this pure rolling and the last problem concept.
Sorry.
I'm not getting
Speak
the
louder.
Sir, I'm not getting the difference between pure rolling and the last problem that concepts. Dif-
Yeah, so last problem has nothing to do with pure rolling. Last problem is that simply a body is rotating with some angular velocity, and this angular velocity can be anything, has no connection with this v, and the center of mass is also moving with some velocity, and that velocity has no connection with omega. Are you getting? So because the two velocities are independent, there is no connection. So this is just a general motion, means rotation plus translation. The difference here is that this point is not in contact with the not at rest, because its velocity is v minus r omega. It is not at rest. But suppose that if here v becomes equal to r omega, v becomes equal to r omega, then think about the velocity of point A. Calculate the velocity of point A if v is equal to r omega. Also, you should understand that when I say v equal to r omega, that v is vcom. So if vcom is equal to r omega, then what will be velocity of point A? Just calculate it like previous problem. Do it. Calculate the velocity of point A if vcm is equal to r omega. The difference in the previous problem and pure rolling is that in pure rolling, V and omega are related. VCOM and omega. But in the previous problem, VCOM and omega, there is no relation. Again, you have to understand that I am saying VCOM and omega, no relation. I'm not saying V particle and omega, not relation. I'm saying VCOM and omega, no relation. But in pure rolling, VCOM and omega, there is a relation. And the relation, this is also not correct, that this will be the relation always, VCOM equal to r. This is also not correct. The only condition of pure rolling is that the point of contact will be at rest. And here, point of contact is not at rest. That is the difference between this and the pure rolling. Here, point of contact velocity is v minus r omega. Here, point of contact velocity is 0. That is the difference. Now it is called as pure rolling. So you will call it as pure rolling only when some body is moving in such a way that its point of contact with the surface, with respect to surface, must be at rest. And this condition is only for pure rolling, not for this situation. Point of contact not at rest. That's why it is not pure rolling. Are you getting difference? You can ask your doubt. Keep asking.
Sir, means general.
Louder, louder.
Sir, can you say any general examples of a pure rolling if possible?
Yeah, this is the example. Any example, like this is the example, or next example you can take. Suppose this is an inclined plane, and on an inclined plane you put a you put a cricket ball, and the cricket ball started rolling in such a way that this point of contact is not slipping with respect to the surface. So generally, if there is sufficient friction between the inclined plane and the ball, and you will put the ball at the top, the ball will come down. You will say that COM of the ball is moving, as well as the ball is also rotating about its COM. But the most important thing is that this point of contact should not be moving with respect to the surface. When I say not moving, it is only instantaneous, means at that instant not moving. And that is true for every instant. But at every instant, same particle is not in contact. No? After some time, this particle will come in contact with ground. After some time, this particle will come in contact. After some time, this particle will come in contact. Are you getting?
Yes, sir, I'm getting, sir.
But at any time, whatever particle, or another best example is when you cycling, or when a person is driving a car, at that time the motion of wheel of the car is pure rolling. So generally, most of the time, the motion of automobile wheels are pure rolling. But if suppose the driver suddenly applies brake, and then this point starts sliding on the road, at that time it is not pure rolling. So generally, simply, if you just take a cycle and you started cycling, at that time motion of the wheel is pure rolling. Tell me, ask again.
Yes, sir, I understand.
Understood? You have any doubt?
I understood, sir. Again, would I will again see and I tomorrow ask the remaining doubts from us. Stop.
Okay.
Sir,
Okay then.
means, yes.
Yeah.
Sir, means here
Tell
V2
me.
minus V1 will be equals to R omega.
Uh, V2 minus V. That is not the correct way of doing it. V2 minus V1 equal to R. That is not correct. Means maybe correct, but then this is not the logic that you will subtract V2 V1 equal to R. That is wrong. How you will derive the relationship means what is the basic, what you will do. So this is the basic. This
It's a
is you
velocity
will
of
do. Velocity of the point of contact you will find,
with
okay,
this, yes, sir.
with respect to the this Planck, and then equate it to 0. From that you will get the equation. Okay.
Yes, sir.
And that equation will be R omega minus V2 is equal to V1. So actually you are getting V1 plus V2 is equal to R. That is the correct relation.
Yes, V1
This
plus
is
V2
the
will be.
answer.
Yes, sir, V1 plus V2 will be equals to relate to that.
Okay, so think about it, keep doing it, and then in the next class come with all your doubts. Okay,
Yes, sir, I will come, sir. Yes.
or you can post on WhatsApp also. Okay, then all the best.
Sir, thank you, sir. Yes,
Keep solving questions from SCV Narayana material.
yes, sir, I'm
Okay.
doing, sir.
Okay.
Thank you, sir.